All right, welcome again, everyone, to the next installment of our Behind BrainPark interview series. Very special guest this week we have on with me is Josh, and Josh has recently just submitted his PhD. So first off, congratulations again, Josh. How does it feel?
Yeah, it feels great. Thank you, James. Thanks for having me on. It's nice to be on the other side.
Yeah, what's the last, week and a bit been post PhD submission been like?
Well, I wish I could tell you that we're tuning in from some nice remote tropical region, but alas, with the current restrictions, it's not exactly possible. But yeah, it's just been nice to chill out, relax, have a few nice sleep-ins, try and recoup and recharge the batteries a bit.
So Josh was one of the first students, PhD students with the group back before BrainPark was BrainPark. I think it was EMSN or BMH back then, and then it went to BMS and now BrainPark. So the group's been through a few name changes. And if you want to see a bit of a transition from what Josh looked like at the start, I think we on our Twitter feed, I might share it in a photo below, the pre and post Josh. The hair and the kind of shirt and everything stayed the same, but they're kind of, this region on your face kind of changed a bit over the years you've been with
That's
the
it,
group.
I haven't aged today, right, James?
So I guess stepping back before you came to the group, tell us a little bit about how you got into science and why you decided to want to do a PhD, and then how that led you to kind of our group.
Yeah, so I guess through my honours research and experiences working as a research assistant before getting started in my PhD, I just became increasingly more interested and fascinated with all things in relation to brain and behaviour and cognitive neuroscience. And I was lucky enough to be able to get my hands on some brain stimulation technology and start tinkering around in the labs, and increasingly became exposed to different forms of neuroimaging, and realised that I really enjoy just the day-to-day life of research in academia, and I guess started to see it as something I could try and turn a career into. So and that led me to start attending a few conferences, and in the context of one of those in Brisbane, met Murat, my primary supervisor, and the rest is history.
Tinkering around with brain stimulation kind of sounds a little bit ominous. That kind of lead in, tell us about your PhD and kind of what the topic is, and then for those who might not have heard of TMS or brain stimulation before, just briefly what that is.
Sure. So across my PhD, I've been looking at the effects of different forms of non-invasive brain stimulation and also exercise on different facets of neuroplasticity and cognitive function. So initially, we were quite interested in this idea of whether exercise and brain stimulation might have additive effects on brain function, and might be a novel angle to perhaps remediate some of the deficits in neuroplasticity that we see in different conditions, be it neurological or psychiatric disorders. In terms of the transcranial magnetic stimulation, it's as I mentioned, a form of non-invasive brain stimulation that is able to directly induce action potentials in targeted neural regions. And so this is quite a fascinating technique in that it's able to causally influence brain activity non-invasively in a painless manner. And this can be used to directly induce neuroplasticity and alter the connectivity of different brain networks that might be somewhat dysfunctional in different disorders and might be contributing to certain symptoms. So at present, the most notable clinical application of TMS is in the treatment of depression, where it's been shown that for those who particularly are treatment resistant, so if failed to respond to, say, a course of antidepressant medication, about a third of those show a clinically meaningful reduction in symptoms. And I'm interested in whether exercise might promote those effects, and whether we can start to look at novel applications.
Yeah, cool. Now, I was actually both a participant in your study as well as an RA at the time, and assisted with some of the data collection. So your participants obviously doing multi-day RTMS. So tell us a little bit about the protocol for your project, and then what are some of, I guess, the main outcomes of your PhD?
Yep. So first off, thank you for your involvement in the project. It's much appreciated. So the project was quite a long-term, arduous undertaking, both on the part of the participants and the researcher. We're interested in looking at, as you mentioned, the effects of multi-day RTMS. So in a format that it starts to approximate the way in which TMS is used in the clinic, where typically patients will come in over the course of multiple weeks to receive daily sessions of stimulation. So I guess the PhD project was initially motivated by some research coming out of Northwestern University, which showed that multiple doses of stimulation to a region of the parietal cortex, posterior regions of the brain, that are functionally connected with a region that's critical for memory function called the hippocampus. Stimulating these networks is able to promote associative memory performance. And this is quite an important form of memory. And again, deficits in these kind of forms of memories underlie a number of different conditions. So it's quite interesting to see these findings, and we're interested in seeing whether we could reproduce similar effects with a similar protocol. And then, as I mentioned, additionally seeing whether exercise, physical activity, or cardiovascular fitness level might influence these kind of effects. So yeah, we set about testing this hypothesis. We recruited a total of 40 individuals, enrolled them in a multi-arm study with 2 weeks of brain stimulation, where in one condition we're targeting the same cortical hippocampal network underlying associative memory function, and then conversely in another condition comparing that to a separate stimulation of a separate network that has been shown to underlie different forms of memory, namely kind of motor learning and procedural memory. So I guess, like all things science, the outcomes of the study didn't exactly match our hypotheses. We didn't see consistent evidence of associative memory improvement following this protocol. So in contrast to these previous findings, we couldn't reproduce similar effects with this multi-day protocol. However, we did see some site-specific changes to functional connectivity. Again, not necessarily in exactly the same direction or manner as the original study, but still some interesting changes to brain connectivity following the stimulation, which is definitely something I'm interested in following up. In terms of the exercise arm of the study, we did some cross-sectional comparisons between different groups that were naturally, in the course of their everyday life, completing different amounts of aerobic physical activity above and below current World Health Organization guidelines. And it was quite interesting to see that looking across these 2 groups, namely those completing high and low levels of physical activity, that we see evidence of different effects on systems of the brain regulating memory. So specifically, we found that individuals engaging in a lot of exercise show evidence of increased hippocampal volume, increased neuronal vitality within this region as well, and that those changes are linked in with increased memory performance. And so this is in a cohort of young, healthy adults, a period of life that I guess we consider cognition and brain function to be at a relatively optimal or stable level. So it was pretty fascinating to see that even in this stage of life, there's evidence that exercise can further enhance brain function and structure.
Yeah, cool. And I mean, the current climate we find ourselves in the world, physical activity, not just for mental health, but as you're saying, for cognition and cognitive health is just super important, and pretty cool that, and whilst it wasn't necessarily a direct outcome from your project, kind of showing some of those benefits of exercise is pretty cool.
Yeah, absolutely. Yeah, definitely. Sorry.
So
I'm interested in, I guess, following up in the long term as well.
Yeah. So I guess two more questions. We'll get to the long term in a sec. But what else were you involved in across your PhD? Were you involved in any other research activities or teaching during your PhD?
Yeah, there were some other peripheral projects that we're looking into as well. So I guess my PhD has, as I mentioned, focused on these interactions between brain stimulation and exercise. But coming back into the lab back in 2015, I was involved in a project run by one of the then doctoral students, Lauren Denoden. And she conducted a study specifically looking at the effects of aerobic exercise on the hippocampus. And we found similar effects. So we showed that engaging in a 12-week protocol of quite high intensity aerobic exercise had demonstrable benefits for the hippocampus and related forms of memory. So again, that was a nice introduction into, I guess, the world of exercise and neuroplasticity, and further proof that exercise is a good thing to be spending our time doing.
Yeah, cool.
I guess in terms of teaching that I've been exposed to during my PhD, for the last year or so, I've been teaching into the graduate diploma of psychology, which is an online program. And my experiences there have been really fulfilling, and it's been a great thing to be a part of, to break up research life as well. So yeah, aspect of academia that I really enjoy.
All right. Lastly, I guess longer term, and it's I feel a bit bad asking, but obviously your PhD is such an enormous thing, and it's just a minute now. It's like, oh, okay, what next? What is the plans for next? Will you continue doing some teaching, some research? What are your kind of plans to move on to?
So the plan at the moment, although not entirely formalized, is to continue research in this area. So looks like I'll probably be looking at more of the acute effects of exercise, and perhaps focusing more on the effects of exercise on skill acquisition, motor learning, and how perhaps the repeated coupling of say an acute dose of exercise and motor skill practice might have facilitatory or beneficial effects. So starting to look at designing a study which looks at whether repeatedly engaging in exercise across the course of a few weeks might further benefit motor learning, which might have some clinical applications down the track to perhaps assisting physical therapy, be it perhaps in rehabilitation settings in relation to stroke, or even perhaps Parkinson's disease.
Yeah, cool. All right. Well, thank you very much for sitting down with me. Good luck with what's next. I'm excited to see how your appearance may grow in the next phase of your research. But again, well done on completing your PhD, and it was very enjoyable being part of the journey along the way. And look forward to any further work we might happen to be doing together over the next few years.
Thanks, James.
Thanks, mate.